And what we have to calculate is delta H naught R of this reaction, the enthalpy change of reaction of this reaction. So let's make our vector triangle. This is A, this is B, this is C. So when we derive a relation, we know that B will be equal to A plus C, and if we apply this to the triangle over here, then we know that minus 1411 is equal to delta HR plus minus 1367. Now this will be equal to delta HR minus 1367. If you see, we have to make the subject we have to change the subject to delta HR. So delta H, actually I forgot to write the naught, so delta H naught R is equal to minus 1411 plus 1367, because this goes on the left. And when I do this on my calculator, just give me a minute, when I do this on my calculator, I get minus 1411 plus 1367, I get minus 44 kilojoule per mole. Units are very important, kilojoule per mole. So this is the enthalpy change of this reaction. This is an exothermic reaction. Now next question. Hydrazine reacts with oxygen according to the following equation. Use the data in the table to calculate the standard enthalpy change of this reaction. Okay, so we are given the enthalpy change of formation of N2H4, and we are given the enthalpy change of formation of H2O, and we also know that O2 and N2 are elements. They are simple elements, so they will not have a standard enthalpy change of formation. So let's write this over here. Now this is N2 gas plus 2H2 gas plus O2 gas. So these are the elements that are involved. These are the elements that are involved in all of these. So this is what we have to calculate. This is delta H naught R. This is what we have to calculate. Delta H naught R. Now let's take this as delta H1. This is delta H2. Now actually let's not take this as delta H1 and delta H2. Let's just put in the values so that we do it quickly. So if you see this arrow, which I labeled as delta H1 earlier, it's nothing but the enthalpy change of formation of N2H4. So this will be 50.6 kilojoule per mole. And then this arrow, which I earlier labeled as delta H2, is nothing but 2 times the enthalpy change of formation of water, because we are given because enthalpy change of formation is only for 1 mole. So if there are 2 moles, we'll have to multiply it by 2, 241.8. Yeah. Now now let's make a vector triangle to simplify, to derive a relationship. This is A, this is B, this is C. So if we derive a relationship over here, we get C is equal to B plus A, right? Now if we apply this relationship to our cycle, our Hess cycle, then what we get is that 2 into minus 241.8 is equal to 50.6 plus delta H naught R. So we make delta H naught R the subject. Let's make it over here. Delta H naught R is equal to 2 into minus 241.8 minus 50.6. So when I do this on my calculator, I get